No everyday engine build today. Once again, horsepower's taken on one of the other engines of high-performance history. A mighty small block from the last great independent car company, AMC.
We love the alternative engines on horsepower. This so-called other engine wasn't from the big three. It was, though, a principal player in the small block muscle car engine wars. In 1967, American Motors was on the ropes in its fight with the big three, but the independent car maker was about to stage a 1-2 knockout punch. First, a new Javelin came out of the gate to mix it up with the pony cars. Then a two-seater AMX entered the performance race to compete with Corvettes. Before long, both cars were Trans Am Series stalwarts, racing, winning, and changing the dowdy image of AMC. During the first years, the most power came from a 325-horse AMC 390, which eventually would get factory stroke to become a 401. Today, find a good used 390 or 401, and you've got the correct engine to build for any classic AMC car. That is, if you can find one, and if you can write the check once you do. But why overlook the 360? Another AMC performance engine first available in 1970. Unlike the other classic pair, the 360 had a 2-decade production life. True to the AMC heritage, yet more correct for a limited budget.
When tearing down a motor, I like to get the distributor and intake off first, so I can get a sneak peek of what might be inside. While we're upgrading the stamped steel rockers and springs, the fact that these are in good condition is a favorable sign. There are specialty tools for removing lifters, but a good old cheap magnet works in a pinch. We noticed divots in some of these lifters. That usually means we're starved for oil. Of course, these are going to get replaced anyways.
Water in the oil pan? That's never a good sign.
While your eyes may be the best tool for troubleshooting an old engine, sometimes your ears are even better. Making compression doesn't sound too great. The rods are moving up and down on the rod journals. We were planning on touching up our crank anyways. We might just actually have to send it off to somebody that actually specializes in crankshafts, maybe have it re-welded up and re-chromed. Ready? With the heads off, it's common to find rips in the gaskets, which are usually signs of leaks. Run in through there, it's got a crack in it. Otherwise, the pistons have a pretty even burn on them, and the cylinders are standard size, 4080, so they've never been previously bored and honed. You can kind of see it right there. You see how it's ground down right there? Mm-hmm. That's where that camshaft was starting to wipe. Now that the crank's exposed, we can find clues as to what that noise was. See right there where it's starting to roll metal down the bottom? You got little shivers. That's where it's gone. That's where our end play come from.
So even though John inspected this thing and even looked inside with a scope, it goes to show you, you never know what you got with one of these things until you get inside it. In our case, apparently we got a good block, but a crankshaft that's going to need some extra work, unexpected. So after loading it up and the rest of our bottom end components, we can take this show on the road to our favorite machine shop.
Stick shift cars are worse than automatic, but it's old. With the thrust here, it's got wear in the thrust flange, and of course the journals have a lot of wear on the mains and the rods.
First step is to grind on the thrust side to create a smooth, clean surface beyond the bad part for welding. But first, the crank's got to be preheated. The heat will help better absorb the weld they'll be putting on the inside of the flanges. From the oven onto the welding table. A heavy bead onto the thrust side flanges of the crank. Then more oven time for a controlled cool down. Most cranks brought in for this treatment are straight. Ours was an exception, but nothing Bo and a couple of tons of pressure can't correct.
All right, I believe we got it. It's within about 2.5 to 3, which is very good.
The crank can now go to the grinder, and here Reese first indicates it so the front and back are exactly on the same axis. Then he can start grinding on the thrust. After getting everything smooth, He's ready to measure the new bearing and the crank for fitment. Still 50 thousandths too small. Here he uses the bearing to check for thrust clearance. After one more pass, a final check using a bearing and a feeler gauge. Now he can chamfer the oiling hose before grinding the rest of the mains and the rod journals.
Meanwhile, John gets busy checking the big ends of our new K1 rods. They have to be within a gram or two of each other. Same drill for the reciprocating rod ends. Next, he weighs the new Pro True forged pistons and their wrist pins, along with the locks and rings. He'll add a couple of grams to factor in oil weight. Bob weights go on the scales to match the weight of all those parts and pieces. John's marking spots on the counterweights where holes will be drilled for slugs. One hole in the front, one hole in the back. The slugs are metal called Mallory we got from Goodson, which is twice the density of steel.
After both slugs are welded, it's time to respin the crankshaft and check results. Close, but close is never enough for these guys.
That's why it's called balancing.
So now why would we throw all this at our crankshaft? Well, because it's not a small block Chevy, we can't just go buy another one. So with a good machinist and a little over $200, our crankshaft will take the RPM range we want to run it in and the horsepower levels. So for you guys out there that have odd engines like this, there are definitely other options.
After major surgery on the crank and more run-of-the-mill machining on the block, we can finally begin the build of our first AMC 360. Hey, today's horsepower is all about the AMC 360, one of the unique other engines in muscle car history, and well, we're shooting for big horsepower numbers with ours without wasting a dime of our budget.
Now we've got all our parts back from the machine shop, but we're not ready to go just yet. And we had them leave a few things so that we could actually show you guys how to do some stuff at home, save a little money, and put a little more of that do-it-yourself pride back in your project. The first one simply involves chasing all the bolt holes. Now if there's any trash at all in one, it can prevent you from getting a good accurate torque reading. Now I like to go ahead and deburr the entire block. Now what I'm looking for is sharp edges and casting flash like this. This is actually what they call a stress riser and can be where a crack wants to start that travels on through. A simple solution, take a die grinder or a sanding pad and work the edges over till it's nice and smooth. It might take a little time, but it's free, and it will make an improvement in strength on an old block. You might even be surprised where you find them. Now while we're still on top, an easy thing to do is just to go ahead and open up the oil return holes to get that oil back down to the pan faster. We're going to do some port matching to improve oiling where it's forced back into the block from the pump. With the timing cover gasket in place, scribe inside the opening of the oil hole, then grind away that extra metal. All right, now let's take a look at our timing cover side, and right here where it goes out, it looks good, no room for improvement. Now we do have one more spot we can fix. This is where the oil comes in from the pan, gets pressurized, and here's the first spot that it goes out. A little restrictive, so we're going to fix that. All right, now we get to work on our main oil galley passage. Now when the oil comes back into the block pressurized, it takes a hard 90-degree turn going towards the lifter valley. It disperses from there. But believe it or not, we can make a big improvement on that. I'm running a 9/16 drill bit into the oil pressure port to enlarge the main oil galley, being careful not to damage the threads. Now I'm going to stop once I get to the lifter galley. That main oil galley right here actually splits once it reaches the top. Now it runs down both sides of the lifter bores. Now the problem with that is the driver's side only has to lubricate the valve train. Passenger side has the valve train as well as the mains. Now the problem with that is by the time the oil gets all the way back here to 4 and 5 bearing, they're starving for oil at high RPMs. So we're going to show you how to go ahead and add a line from the front to the back right there. Go ahead and pressurize that system and get a lot more life out of your bearings. We start by drilling a hole here by the number 8, tapping it for threads, and installing an A-in-line fitting. We follow the same procedure where the lifter oil galley splits. Because the line we're running from the front to the back will increase the oil pressure on the passenger side, I'm going to show you guys how to go ahead and restrict it on the driver's side. First, you run an 1/8" pipe tap where the oil galley splits into the driver's side. Use a vise to hold a pipe plug while you drill a 150 thousandths hole into the center of it. Then, thread it into the hole you just tapped. Now here's something to watch out for. Now this passenger side oil galley has to get plugged off, but we're not ready just yet. There's an oil galley that runs down behind it into the #1 cam bearing. Now if we restrict that flow, we're gonna have some serious issues. Now it's a common mistake to go ahead and take the pipe plug out of the package and just drop it in. It's not gonna work, it's too long. So what I did was actually take it and turn it down about half its distance on the lathe. A belt sander will work just fine, just make sure you don't booger up the threads. After cleaning up the freeze plug holes, all the block mods are done. Now it's bath time for the block. We're using our sonic cleaner and some elbow grease, but it's well worth the money to have the machine shop do the job for you. After some WD-40 to prevent rust, I'm using some old parts as masking for the paint. With some Loctite sealant, we can go ahead and knock in the freeze plugs. To save money at the machine shop, we're doing all the pre-assembly ourselves, so we need to start off by miking the rods and mains. With main bearings in place, drop on the main caps, torque them down, and compare the numbers to get your clearances. With the rod bearings installed, we can check them for clearances too. With just a little oil first, install the camshaft, see if it spins freely. After the crank, then install the 3 main caps, front, rear, and thrust. Install the timing set, connecting the 2. I'm putting our forged Wiseco piston and K1 H-beam connecting rod together and into the #1 cylinder. I like to put a piece of tape around the ring lands just to protect them during mock-up. Let's go ahead and check the cam against the card. All right, now a lot of guys are having trouble with their distributor gears burning up on these motors. AMC never offered a cam button from the factory, and as you can see here prior when we tore this motor down, our cam button was getting into our timing chain cover. So what we're going to do to fix that, we're going to take a nylon button for a small block Chevy, chuck it up in the lathe, see if we can't take some of that walking pressure off that distributor gear. I used a new grade 8 bolt and just turned the head down a little till it was flat and smooth. Go ahead and round off the edges so you don't cut the button apart while it's running. Then I bored the button out to fit around the bolt head freely, as well as turning down the snout. With a dab of grease to hold it in place and the timing cover on, check the end play. Finally, with 2 lifters installed, along with our cylinder head, we can go ahead and check for push rod length. Now you can see our sweep area right here is a little bit too far to the top side of the valve. That can actually cause unwanted pressure in the wrong way on the valve. So what we're going to do is adjust it and see if we can get it to move out a little further. Spot on. Finally, we can make an order. Now all this pre-assembly that we've been doing, well, it can be pretty time consuming, but it's nothing that you can't handle by yourself at your house with just some basic hand tools. Believe me, it can actually save you a lot of trouble when you're doing your final assembly, which we're going to get to when we get back.
We are back. Just in case that pre-assembly work that John showed you seemed a little bit intimidating, here's another option. If you got the budget, have your machinist assemble the short block for you and you can do the rest of the work. Of course, we've assembled ours and we're ready to finish this AMC.
Our cam's a solid flat tappet from Comp that we had them grind for this engine combo, as well as spec out the rest of the parts for the valve train. And with a solid lift flat tappet, we could get a more aggressive grind without shelling big bucks for a roller. And we used the money we saved for a nitride treatment. With the timing chain in place, we can go ahead and cinch down a new timing chain cover from Summit Racing. For an oil pan, we had 2 choices. Now Summit offers this one, which is for a 4x4 application with a steel reinforced bottom end. Now Mylodon offers this one, which is for a road race application. We also got one of their pickups to use with it. Now this pan may cost a little more up front, but it needs no modifications to fit into an old AMC car. For a bouncer, Summit sent us this one that's SFI approved. Now believe it or not, these Edelbrock Performer RPM cylinder heads actually cost us less to buy than it would have to send the old ones out and have them reworked to anything close to the performance levels these will give us. Plus these come with a 54cc combustion chamber, 180cc intake runners that have been completely CNC port matched, as well as a 5/8 inch thick deck. Now where that's going to help you out is if you guys are running a little bit of boost or some nitrous hits, you're going to want that thick deck. However, they come assembled for a hydraulic cam, so the springs and retainers, they're coming out for a swap. Before replacing them, I'm going to go in and open up these old return holes. After cleaning up the heads, we can install these comps with more spring pressure, which our solid flat tappet cam needs. Now hydraulic wouldn't run more than about 110 pounds on the seat, we'll be running about 130 and about 370 open with 100 thousandths clearance for coil bind. That combination is going to work great with these flat top Lysco pistons. And even with these big old valve reliefs, we're still going to be in a street strip compression ratio of 10 3/4 to 1. Because of the higher spring pressure, we're going to run a 1:3 ratio rocker on for braking only. This will allow the valves to open up just enough to run without wiping a lobe during the initial fire up. Well, we've gone over a lot of oiling mods, so I'm going to go ahead and prime this engine out here. That way, if we have any issues, we can go ahead and handle them now without wasting time in the dyno room. There's an oil pressure gauge on this bracket I made out of scraps, just to give us a quick reading on the PSI. That's right where we need it. To feed our 360, a Summit Street Strip 750 carb mounted on Edelbrock's Torquer 2 intake and an adjustable gooseneck from robmcperformance.com, all ignited by an MSD Pro billet. We gave it a 30-minute warm-up before replacing the break-in rockers with these 1.6s from Comp. With the timing locked out at 36 degrees, we're making several back-to-back pulls at 5,000 RPM. Now, as the rings continue to seat, the horsepower will progressively increase. 426 is our best horsepower number at 5,000. Now it's time to see what 6,000 can do, after replacing the break-in oil for some purple stuff. Purple oil, purple oil.
I still don't think Simon Cowell would be proud, though.
No, I don't think he'd be proud, but I bet he wouldn't talk to me like he talks to everybody else, too. I think I sing good.
Boy, she sings. 446,
446.
426. Nice, nice.
It's running a little rich, so I'm adding 2 degrees of timing. And this time, we'll take it to 6,500.
440, 423. We went a little fat on their fuel that time. That's where that power went.
We're leaning it out some more with smaller jets, 2 sizes front and back, and discovered where that smoke came from. This PCV line was feeding oil straight into our carburetor and found out the plugs. A baffle will fix that later. We're gonna do 1 to 7.
You want it, don't you?
I want it bad, man. I want to see what this thing does. Give it to me.
All right, 7 grand, here she comes.
477.
432.
Yes.
Very cool.
A 360 with the 4-barrel package back in the day made about 295 horsepower. We've already beaten that by almost 200, and we've only got about $6,500 into this whole project. Now that'll definitely take the all my cash out of AMC.
I'd like it in a little rock crawler, a little rock buggy.
I love you. I love everything about you. Oh, I can't.